Hello there, friends and neighbors. Now I'm going to show you how to do a chi-square goodness of fit test, which is what you do when you have one categorical variable. And so we're going to do that in the context of Real Data Homework 1. Real Data Homework 11. Then the other half of Real Data Homework 11 is the two-way contingency table chi-square test of independence. We're going to do that next. That'll be another video. So I'm going to scroll down to the Unit 11 assignments to Real Data Homework 11. Now don't click on this until you're ready to choose your group members. If you want to work on this as a group, I absolutely encourage that, but you have to choose the names and then record the group and continue. I think you might be able to add members after the fact, but I'm not 100% sure. And so if you have trouble with that, let me know. But the bottom line is just don't click on it until you're ready to decide whom you want to work with in a group. Okay, so the first thing we want to do is download the data set. It's right here. Just right-click, Save Link As. Okay, and I've already got it saved, so I'm not going to save it again. Here's a written example of how to solve the exercise from beginning to end. Here's where I'm going to put the YouTube videos I'm making right now, so they will work through the example from beginning to end. And so now we're ready to get started. So we're analyzing the data from the first day of class, and I'm going to start with two categorical variables and choose the one that is most appropriate. The two variables we're going to start with are recipe for this quarter. Now let me pause on this. The variables are not always going to be the same, but the steps are always going to be the same. And the numbers, of course, are never going to be the same from one quarter to the next. So this is an example that we're going to do. Anyway, so we're going to start with recipe, which is the student's favorite potato recipe, and recipe simple, which is a simplified version of that same variable. We hypothesize that in the population, all recipes are equally popular, so they all have the same population proportion, P. Okay, so first I'm going to open up the data set, which I've already done. You open up R, then R command, then ECR. Actually, I'm going to close it and start all over. Okay, so you open up R by double-clicking on the R icon. And then if you don't have R commander set to auto-load, you can type the command. It looks like this. Library, open parenth, capital R, lowercase cmdr, close parenth, and hit enter. Mine doesn't need that because it's set to auto load. Once it is loaded, you have the R commander. You go Tools, Load R Commander Plugins, and you choose the Easy R plugin. Again, mine is set to automatically load. But you have to do that every single time unless you set it to auto load, which you can learn about in the earlier videos. So File, Import Data, Read Text. So you have to download the data file someplace that you can save it again. Maybe give it a cool name like Class E because they're class data. Okay. And then data from Stat Survey is what I called it. So open it, and now I've got the data file open. I'm ready to go. Let's read the first question. For recipe, how many categories are there? Let's find out. So statistical analysis, discrete variables because it's categorical, frequency distributions. Then I'm going to choose recipe. I'm going to turn on the chi-square goodness of fit test, turn off the show missing data, turn on the show percentages, and turn on the show the graph, because those are the descriptive statistics in the graph, things that I want. So I click OK, and boy, that's an awful looking graph. Looks like there are 43 categories. If we hypothesize them all to be equal, then each P is 1 over 43. That's actually all I wanted to know right now, so I'm going to turn that off. I'm going to put away the graph, and then I'm going to say the answer to this question, which is 43. Since HO is that in the population all recipes are equally popular, therefore, each recipe has the same hypothesized proportion P. What is that? Well, it's 1 over 43. Maybe I expressed that as probably should express that as a proportion, so equals 1 over 43. 0.0232, yeah. I'll round it to, I don't know, 4 places. Okay. For recipe, what sample size is there? What's the N? Well, I can look here in R. It's kind of a complicated way to do it. I'm just going to open it, I think, with Excel, with my favorite spreadsheet, and that will let me do it. So, data from Stat Survey. It's pretty convenient to open it up with Excel. And I'm going to sort by, select the whole data table and data sort by recipe. Let's set the range to contain row labels and sort by recipe. And that way I can count how many different recipes there are. There it is. All right, so come over here, and looks like there are 49 different recipes, because the first row is just labels. So 49. Well, 49 people answered meaningfully and 43 different answers, so that tells you something. This is what happens when you leave a question open-ended. You get answers like this. Very slight variations count as a totally different category, so it's something you have to keep in mind when you're designing your own surveys. Since HO is said in the population they're all equal, what's the expected frequency? Well, that's N times P. So I'm going to come over here to my spreadsheet that I was working with. And there's my P, and N we decided was 49. So equals 49 times, there's N times P. For every group, it's 1.14. I'll just copy it over there. Paste it. 1.135, I'll call it. Yeah, 1.395. Now, does recipe meet the assumptions? No. The assumption is that all expected frequencies are at least 5. So for recipe simple, how many categories are there? So recipe simple, this is a different question. Statistical analysis, discrete variables, frequency distributions. And this time I'm going to choose recipe simple. Okay. And I forgot to choose the options I want. Statistical analysis, discrete variables, frequency distributions, recipe simple. Choose the chi-square. Turn off the show missing, show the percentage, show the graph, and click OK. And there are 6 different categories. I'm going to click OK, so we'll run the analysis, which is the null hypothesis that they're all equal. And 1/6, so let's figure out what that is. Equals 1 over 6. So it's 0.166667. So 0.16667. For recipe simple, what is the hypothesized proportion for each group? Oops. There you go. There are 6 groups. For recipe simple, what is the sample size n? Well, I'm going to go do that same trick I did with the spreadsheet. Select all the data. Data, sort. Data, sort by recipe simple. There it is. And now I'm going to go count how many recipe simples there are. And it looks like there's 1 fewer, so there was, instead of 49, there's 48. The first row is labels, so 48. And that is equal 1/6 times 48. I get 8, an expected frequency of 8 for each group. All right, so the sample size is 48. The expected frequency for each category is therefore 8. Does this meet the assumptions? Yes, it does. Which variable should we use? Well, the one that met the assumptions was recipe simple. That's what we're going to use. Now, what are the assumptions for chi-square goodness of fit test? All expected must be at least 5. All expected frequencies must be at least 5. Let's see if it marked me as right. Yes! Yes! Everything but the essay question, which I have to grade by hand. Well, that first question is longer than others, so I'm going to stop now.